Welcome everyone. Today I'm excited to present you the ScanBot, the essential component of our advanced robotic sanitation system. We'll explore its design, components, functionalities, and understand how it ensures a pristine environment. Let's begin with the external render of the ScanBot. As you can see, it features a compact design with dimensions of 16 inches in length, 16 inches in width, and 7 inches in height. This size ensures that it is both compact and maneuverable, allowing it to navigate through various environments efficiently. From a side view, we can observe the robust yet sleek design. The enclosure protects the internal components while maintaining easy access and maintenance. The wheels and chassis provide stability and smooth movement across different surfaces. Here is the top view of the ScanBot, highlighting its strategic placement of sensors and modules. The layout ensures optimal coverage and functionality of all components, allowing it to perform its tasks with high accuracy and efficiency. Looking at the bottom view, we can see the motor placements and bumper safety features. These bumpers and force sensors provide collision detection, enhancing the safety of the ScanBot as it navigates through its environment. The perspective view gives us a comprehensive look at the ScanBot, showcasing how all components come together in a cohesive design. The placement of each element is optimized for maximum functionality and efficiency. Moving on to the internal components, let's dive into the heart of the ScanBot. It houses a variety of sensors, motor drivers, and other essential components that enable its advanced functionalities. The component layout is meticulously designed to ensure efficient space utilization and easy access for maintenance. Each component is strategically placed to work in harmony with others. Here's a close look at the sensors and modules. The ultrasonic sensor detects distance from obstacles, while the UV light sensor identifies potential biological contaminants. Temperature and humidity sensor provide environmental data crucial for the ScanBot operation. This section highlights the power supply communication modules. The battery pack powers the ScanBot. The microcontroller shields or modules such as Bluetooth and Wi-Fi enable seamless communication with other cleaning robots and control station. Safety is paramount. The ScanBot is equipped with bumpers that act as safety features to prevent collisions. This not only protects the robot, but also ensures a safety environment for others. Now let's look at the circuit design. This diagram provides an overview of how the electrical components and interconnected ensure smooth operation of the ScanBot. This detailed circuit layout shows the connection between Arduino boards, motor drivers, sensors, and other components. It is crucial to understand how signals are processed and actions are executed. Power distribution is critical for the efficient operation of the ScanBot. This diagram illustrates how power is allocated to different components, ensuring they achieve the necessary energy to function optimally. For the next 5 slides, I'll dive into the code that drives the ScanBot. I'll be displaying the code snippets and highlighting key sections that control various functionalities of the robot. Here is the activity chart diagram. I'll walk you through the optional flow of our system using this flowchart. We'll start at the initialization of the system components stage, where all necessary system components are initialized. Once the system is ready, it moves on to receive commands, where it waits for user inputs or commands. Next, we have a decision point, decision commands invalid. Here the system checks if the received command is invalid. If the command is invalid, it goes to error handling for the commands to address the issue. If the command is valid, it proceeds to set motor direction to determine the direction in which the motor should move. After setting the motor direction, the system performs a sensor reading to monitor the environment. It then reaches another decision point, decision obstacle. If an obstacle is detected, the system will stop reverse motors to avoid collision. If no obstacle is detected, it moves to read other sensors to gather additional environmental data. Following this, the system checks the gathered sensors data at decision sensor threshold exceeded. If any sensor threshold is exceeded, indicating an alert condition, the system will update the LEDs for alert to signal the issue. If the thresholds are normal, it will update the LEDs as normal accordingly. Finally, the system will send status updates to inform the user of the current status and return the receive command stage to await further instructions. This loop continues until the system is turned off. This flow ensures that the system operates efficiently, handles errors appropriately, and continuously monitors the environment for optimal performance. And next, I'll show you the actual code. Now let's move on to the live demonstration. We'll watch a video showcasing the simulation of the ScanBot in action. This will give you a real sense of how the ScanBot navigates, scans, coordinates with other cleaning robots. Hello everyone. Today I'll be presenting my ScanBot project. My robot integrates various sensors and actuators to perform complex tasks autonomously. The primary goal of this project is to demonstrate how the robot can navigate its environment, detect obstacles, and respond to different environmental conditions using a combination of motor control, ultrasonic sensors, LEDs, and communication. Let's delve into the key functionalities of my robot. All right, first things first, we have the L293 Delta driver, and then we have the DC motor. This controls the movement of the robot. Then we have the ultrasonic sensor, measures the distance of obstacles and prevents collisions. Now to the environmental sensors, I have the force sensor. This detects pressure and forces applied to the robot to go in reverse if runs into a wall or an object. You have the gas sensor. This monitors the presence of certain gases within the environment. And then the temperature sensor. This measures the ambient temperature within the environment as well. And then you have the UV sensor. This detects any contamination within the room that needs to be cleaned or verified, needs to be checked. And then if there is a contaminant, the robot will send a signal stating that there is something that needs to come back to be cleaned. The LED strip. The LED strip changes into different colors to provide visual status indicators. It changes colors to reflect the different statuses such as scanning, alert, and all clear. The microbit sends and receives signals to and from the microbit to remote control and status updates. So this microbit is the ScanBot communication to send signals to this microbit, which is the central control station. And then the central control station can send signals back to the ScanBot to tell it to engage or stop. Now to the actual sensors. So right now the robot is not engaged, so the central station will send a engage signal. So now the robot is going forward, and then in the serial monitor you will see the signal is engaged. Also, the central control station can tell the robot to stop. The robot has stopped, and it sends a signal to the microbit and to the serial monitor saying that the signal was sent to stop the robot. Let's go back to engaging. Now, let's do the force sensor. The force sensor, if any of the bumpers gets pressed within the robot's range of, like if there's a table or if there was a bed, or some kind of object that got in the way, or a human was walking by and hits the sensor would be pressed. The robot would go in reverse for a few seconds and then try to go forward. And go back to forward once the force pressure is gone. Next, the ultrasonic sensor. So if an object is getting too close, the robot will stop and then go into reverse mode. And then once the back side of the robot gets too close to a wall, the robot will do the same thing for the ultrasonic sensor for the back end as well, and then go forward. Let's see. And also within the serial monitor, it also sends and receives signals from the Arduino to state what is going on within the robot. For the gas sensor, if there is any contaminated gas, it will send a signal stating the red LED saying there is an alert, saying that there is too much gas within that room from the fumigator, and then send signals to the central station as well, which I can present later once this clears. When it clears, it turns green and then yellow back to saying it's scanning. And at the same time, it should send a signal to the microbit stating that it's all clear. As here it shows clear. So if there is an alert, it sends a signal to the central station stating that there's an alert. And then back again. Once everything's clear, it will turn green. And then back to yellow to scan. And then sends the all clear signal, which is the C symbol. Temperature, any fluctuation within the temperature within the room will send an alert, and also sends it to the central station. And then once the temperature goes back to normal, it will send an all clear and then go back to its normal scanning. All right. Now for the UV sensor, if there's any contamination, even though this is a passive infrared, this is just a simulation stating that this is a UV sensor. So it's saying that there's contamination detected. And then once there's no contamination detected, it will send a signal back to the central station that it's all clear. It's all clear, sends a signal. And then also, you can also type in commands within the serial monitor to go backwards. As you can see for the robot, we'll zoom into the motors real quick. So now it's going backwards, forward, left, right, and then also stop. And then the forward command is engaging. And that is the demonstration of my robot. Thank you. In conclusion, the ScanBot is a pivotal element in our robotic sanitation system. Its advanced sensors, robust design, efficient coordination capabilities make it an indispensable tool to ensure a clean and safe environment.